Start with Chapter 7, Section 3, Multivariable Linear System. And this time we mean just basically more than two variables. So you saw some examples on your homework on that pink sheet that had three variables. Christiana and Gianna, do you have a method? Did Google give you a good method?
What you do is you pick or you do elimination to find one of the first variables. So you do you could do the top and the bottom for the two top ones, and then the top and the bottom one, and eliminate say Z, because that will eliminate pretty easily. And then you'll be able to find, you'll just have two variables to work with.
Very good. So basically if you did some research or you look back in your Algebra 2 notes, you're going to pick two equations at a time and eliminate a variable. And you're going to do that twice with two different sets of equations so that you have a two-variable system that you can solve like normal. Fiona, is that basically what you're going to say? Okay, so here's my system for organization that I think will be super helpful, not only to me, but also to you when we go back and we check our work and see if we can find our errors. You heard Christiana talking about okay, you could take the top two or the bottom two or the top and the bottom. I'm going to go ahead and label my equations. A, B, or D. Oh, you did this?
I remember this.
Yay!
I remember the R1, R2, R3.
Working on something to circle.
Oh, what do you do?
We did R1, R2, and R3 because row 1, row 2.
Did everybody do R's?
No.
That's what Mr. Abel taught us.
Okay, either one works. Now, the R, row 1, row 2, row 3, is actually going to carry over very nicely into matrices, which is our next chapter. So there might be a reason why Mr. Griebel chose R's. If you want to do R's, that would be cool. If you want to do A, B's, and C's, that's also fine. So you take your pick, whichever you choose. All it does is serve as a reminder for us when we do our following steps, which equations we actually started with and what we decided to do with them. Okay, so then this is the part where I tell students to maybe try to think smarter and not work harder. What would be a good variable possibly to work with in terms of eliminating it twice? X. Why would you choose X?
Well, because two of them aren't numbers void or anything.
Okay, so two of them have coefficients of 1 and don't have a coefficient anything else. Anybody else want to make the argument? Maddie?
You could do C because A and C, you can already cancel out Z.
And yeah, I would say Z's are a lot like what Saban is describing with his X's, that they both have coefficients of 1. But I might actually choose Z's only because one is positive and one is negative. So you could certainly choose to eliminate X. Okay, if you wanted to. We're going to go ahead and eliminate Z. So I'm going to mark this down. Eliminate Z. And then I would do like Maddie said, choose the first A and the last C. And I actually labeled them, or you could have R1, R3 right there. And then I'm going to do 2x plus 4y plus z equals 1. On top, then x plus y minus z equals negative 1. And what am I doing with those two equations? Yeah, you're stacking and adding the equation. So I'm adding down, and I would get 3x plus 5y equals 0. Okay, now I usually label that then as another equation, so I've already used up A, B, and C. I'm going to go ahead and label this equation B, because that's going to be my first equation in my two-variable system. With 3x plus 5y equals 0, I don't have enough information to solve for x or y, so I need another equation that has two variables, just x, just y. So I'm going to eliminate D again. This time I'm going to have to use B with one of the other equations. Which equation would you use? A times 3. Then it will be positive 3z, and B would be a negative 3z. So I'm going to do A times 3 and B. Okay. And again, I think that this method, whether you're using R1, R2, R3, or you're using A, B, C, whatever you do, label something. And then you can write out to us what you were trying to do. That way we'll be better able to find mistakes as they occur. So distribute the 3 to everything. That's 6x plus 12y plus 3z equals 3. Probably most common mistake is to forget to distribute to the number. On the other side, that happens all the time. You guys remember these now, don't you? One tiny sign error or multiplication error ruins everything. Did I do okay? No, I wrote C.
Yeah.
Thank you, Spawn. Right B. Thank you. Okay. So then again, we're stacking and adding. So I'm going to add down 7x plus 10y equals 5. And I'm going to go ahead and label that E. So think back again to how Christiana was talking about her process. She's going to eliminate a variable 2 times using 2 different sets of 3 variable equations. Now, D and E, I'm just going to write them, and I wouldn't always rewrite them, but I'm going to write them like this one time. Now D and E represent a 2 variable system. Looks like numbers 1 through 4 on that worksheet I had you do over the weekend. What would you do to solve the 2 variable system? Yeah, multiply D by negative 2. Okay, so I'm going to let you guys solve this and see if you can get an answer. See if you can get a full solution. Row 1. Oh wait, that's what that one is, right? Okay, and then what did you do? You multiplied it by negative 0 and negative 2. Yeah. Yeah, good job. Whew. I know I hate these because it's like half a page for one problem.
And I
would always do something wrong.
Yeah, and then you mess up, and then you would recheck, and then you'd be like, whoa.
Yeah, and then you're like, what about the third variable?
Because then you see that it's like 5.
So you solved the 2 variable system, but you really want to solve the new variable.
Oh no.
Okay, so I'm walking around. You guys are doing a good job here. Most of us decided to multiply D by negative 2, so then you come up with the solution x equals 5. Okay, so that one's nice. After you find out x equals 5, you can now solve for y by plugging x equals 5 back into one of the equations. You think one of them is easier?
I mean, we do B and C. The Y.
Oh, you would plug into D? Okay, so we're going to sub x equals 5 into D, and that will allow us to solve for y. So 3 times 5 plus 5y equals 0. That's 5y equals negative 15. And so y is equal to negative 3. Okay, and so at that moment you've only solved your two variable system with equations C and E, but remember that's not your original problem, right? That's part of your work. So now you've got to sub x equals 5 and y equals negative 3 into one of your original equations. Does it matter which one? It doesn't matter which one, but some people are saying do C. Yeah, I think you can look at the equations and say, okay, there's less I'd have to divide by or less I'd have to multiply. These numbers are going to be smaller. I do think that you can work smarter on these problems. So let's see, that's 5 plus negative 3 minus z equals negative 1. And then that's 2 minus z equals, oops, was that negative 1? Equals negative 1. So negative z equals negative 3. Therefore, z equals 3. What should your answer look like? Order triple, x, y, z. So we actually solved in order x, y, z, but make sure that you put them in the order triple in the correct order. Okay. So your final answer here will be 5, negative 3, 3. What's that, Tegan? You could plug them back into equations A and B and make sure that they actually worked out, right? If you wanted to verify that you were correct. Absolutely. Okay. And if you had extra time on your test next Friday, I might do that. If I didn't have extra time, I'd be very careful and write down all my work as I was solving. All right. Does that help us feel a little bit better about solving three variable systems?
Yeah.
Okay, very good. Now, we're going to talk about a case that you probably saw last year with three variable systems. And it's one of those interesting cases that we saw with two variable systems, but in pre-calc we're going to do a little extra. Okay? So I would jot down this three variable system.
Is that representing a blank or just saying like it's like?
It just skips where y is. I think the textbook might do that. So it's like x plus 0y plus 2z.
Yeah. So do you need to write the 0, 1?
No, you do not need to write it. So x plus 2z equals 5. 3x minus y minus z equals 1. And 6x minus y plus 5z equals 16. And maybe on this one, some of you say you multiply or you name them R1, R2, R3. And so you could do ABCs or you could do R's. What are you thinking might be nice to eliminate? Yeah?
If we did the y, then you would already have your second one, so you don't have to do it once. So you just do like R2 times negative 1, and then you have to divide it.
Yeah, this equation R1 is already only in two variables. So if we choose to eliminate y with the other two equations, then we'll have two equations and two variables. So yeah, that's not a bad idea. Which one are you going to multiply by negative 1?
I said R2.
R2 times negative 1. And R3 is what we'll use. Okay, so that's negative 3x plus y plus z equals negative 1. And then 6x minus y plus 5z equals 16. I stack and add those, and I get something like 3x plus 6z equals 15. I'm going to call that equation D. And now this is just in terms of x and z. This is just in terms of x and z. So what would you do to solve for one of your variables?
You try to multiply with
Okay, which one do you want to cancel out?
X.
X. So we'd have to do R1 times 3 times negative 3, so that it will be the opposite. And then we'll keep D as it is, correct? So someone said eliminate x. We have a positive 3x, so we want it to be a negative 3x. So we would have negative 3x minus 6z equals negative 15. They all go away. So we say this one is infinitely many solutions. Okay, now, because we're in pre-calc, we are going to kind of label still a set of order triples that represent the infinitely many solutions. In order to do that, they have to be written in terms of some variable. The most common thing is to pick one of your letters. It doesn't matter which one, but most of the time the book will let z equal a. Okay, so they're just going to say let z equals a. Could you say let x equals a? Could you say let y equals a? Yeah. In my homework, I let z equals a. So if you want your answers to look the same as mine, let z equals a. Okay, now we know z is a. We want to find x and y in terms of a. So if z is equal to a, we can go back to equation D, or we can go back to equation row 1, and we can sub a in for. You see me jump?
Yeah.
Ghost. So let's put it into probably R1, right? Sub z equals a into R1 and solve for x. So x plus 2a equals 5. That means x is 5 minus 2a. So whatever z is, whatever point I am that is infinitely many solutions, x is 5 minus 2 times a. See how I'm doing that? I'm dividing it in terms of a's. And now I need to figure out what y is. So I'm going to plug z equals a and 5 minus 2y into R1 or R2. Does it matter which one you choose?
No.
No. So I'm going to do, I think, R2. So z equals a and x equals 5 minus 2a into R2 and solve for y. So R2, 3 times 5 minus 2a minus y minus a equals 1. So I have to do some distribution. 15 minus 6a minus y minus a equals 1. I might combine my like terms, negative 7a minus y, and I'm going to move negative 15 to the other side, so I get negative 14. And then negative y equals 7a minus 14. So y equals the opposite of that. Yep, so you could say negative 7a plus 14. You can say 14 minus 7a. Both of those are the same thing. And then you can plug that in for your y value. So it's just a little bit of algebra, right? Substitution and solving. Key here is don't solve for a. Solve for the variable. Z is a. Solve for x in terms of a. Solve for y in terms of a. So you want your final line to look like x equals or y equals. And then I can go back up to my original problem and put that in. Now, what that means is, like if we had a two-variable system, I'm going to say 14 minus 7a. If we had a two-variable system that was infinitely many solutions, we could do the same thing. We could say, like, let y equals a. And then we would plug back in and solve for x. And all that means is we now, as we plug in different numbers for a, we're finding all the points on that line. Good. Now, you might encounter one additional type of problem, just FYI, on the homework, and that's a non-square matrix. A non-square matrix just means like the number of equations don't match the number of variables. So if you came across something like this, just be aware that you're going to do what we just did. You're going to get it down to two variables, and you only have two equations. So you can eliminate one variable. And I might eliminate x's. And then I would start that whole process of, okay, I can't do anything else, so let me just let z equal a, let me solve for y, let me plug back in and solve for x. And so if the variables, number of variables don't match the number of equations, then you're going to have a long list of solutions. So you use a, and that's it. Now, you have homework, so there's really 4 required problems. I know that these take a long time, these take a lot of paper, but certainly if you've got a little extra time tonight, put in some time with the others. 474 and 484 are more review over what was on the pink sheet, so I do expect you to be able to solve two variable systems and nonlinear systems. You're going to take a quiz on 7-4 this Friday. The 3 variable system's not going to be on that quiz, they'll be on your problem set. Chapter 7 test will be next Friday, so if you're absent one day, you gotta get those notes immediately. And then if anybody is interested in their Chapter 3 test retake, you should be checking out your test from me. There is a 10-question review assignment from the textbook over there on the board on page 252. So you make corrections to your test, you do this correction assignment, and the deadline for that is Tuesday, the 24th, so that's next Tuesday.
If this one on the quiz, what is wrong?
Just 7-4, partial fractions, which we do on Thursday.
Oh, okay.
That's just 7-4.
Yeah,
we haven't done that. It'll be just the new stuff.
Oh, yeah.
Yeah, you're really